If your understanding on the Big Bang Theory has to do with an explosion of a tiny object, you probably have it wrong. What then is the Big Bang Theory? And are there actually proofs to show that the Big Bang Theory is correct? Well, stay with me to find out.
Welcome to AJ Sports with Ezekiel, the Unapologetics Bold Apologetics podcast. This is your space to grow in faith, defend what you believe, and respond to hard questions with wisdom and truth. Let's dive in, listen, and be edified.
Today we are going to be looking at the Big Bang Theory. And if you're a Christian, I want you to pay attention because not everyone who believes in the Big Bang as the origin to the universe do so on blind faith. If you're a skeptic, I want you to also pay attention because you might just get extra evidences that supports the Big Bang. This episode is not about making fun of those who believe in the Big Bang, but rather having an understanding of the Big Bang theory and looking at evidences that support this theory. Even though I'm an unapologetic Christian apologist, I'm going to be doing my very best to bring forth the best evidences and arguments that support the Big Bang theory. The Big Bang Theory is the most widely accepted scientific explanation for how the universe began. And the Big Bang Theory says that the universe had a beginning around 13.8 billion years ago. Space, time, matter, and energy was packed into a tiny hot dense point of singularity. Then in a moment of rapid expansion, it began to stretch out and grow bigger and cooler. So it's not about an explosion of a tiny object into space and then things began to form. No. Space itself began to expand from a tiny hot dense point of singularity. So before the Big Bang, there was no time, there was no space. Then at the moment of the Big Bang, time and space started. During the first few seconds after the Big Bang, particles like protons, neutrons began forming. The universe was so hot at around 1 billion Celsius, and it was dense to the extent that particles kept colliding into each other, forming two chemical elements named hydrogen and helium. And then as years passed, the universe kept expanding and cooling down up till around 380,000 years after, and the universe was cool enough for light to freely travel around the universe. That first light that freely traveled around is what we know as the cosmic microwave background, which we'll talk about later on in this episode. At about 100 to 200 million years after, the first set of stars began forming from pure hydrogen and helium. Galaxies began forming as stars cluster together under gravity. And then about 1 billion to 13.8 billion years after the Big Bang, galaxies began to increase in size just as the universe continued to expand. There were superclusters and planets began to form as well. Some interesting things to note is that according to science, our galaxy, Milky Way galaxy, began forming about 13.6 billion years ago. Our solar system began forming at about 4.6 billion years ago, and Earth is around 4.5 billion years old. The Big Bang Theory challenges old beliefs that the universe is eternal with no beginning and no need for a cause. It was previously believed that the universe was static. But in 1915, Albert Einstein published his theory on general relativity. And then in 1927, George Lemaitre used Einstein's equation to propose a model for an expanding universe, which he referred to as the hypothesis of the primeval atom. George Lemaitre's hypothesis was that if the universe is expanding now, then it must have been much smaller in the past. Maybe it all started from a tiny point. In 1929, Edwin Hubble's observation of galactic redshift provided compelling evidence that galaxies are moving away from the Earth, which directly supports the idea of an expanding universe. The term Big Bang itself was actually coined in the 1940s by Fred Hoyle, who disagreed with the theory and used the term Big Bang mockingly on a radio program on BBC. And that name stuck. That's why we call it the Big Bang theory and not actually theory of primeval atom. So what are some evidences for the Big Bang theory? Are there actually evidences? Let's start with this redshifts of galaxies. When scientists observe the light coming from other galaxies, they notice that the light is stretched and the light becomes more red in color. So redshift just means light shifting from a brighter color down to color red. A good example so we can all understand is how we all know the sound of siren or of an ambulance. When it's farther away, it's lower in pitch. But when it's close to our location, it's higher in pitch. It's the same siren, but sounds differently based on its location. This is because the sound wave of the ambulance siren takes a long distance to travel to our ears. So it stretches over that long distance. But when it's closer to us, the sound wave doesn't have to travel far to get to our ears, and so we can hear it at its actual high-pitched sound. How is this an evidence for the Big Bang theory, you might ask? Since the redshift of the galaxies proves the galaxies are shifting away from us, it means the universe is expanding on every side. And if the universe is continuously expanding, it means the universe started from a much smaller state than it is today. And according to the Big Bang theory, it started from a hot dense point. Another evidence is the cosmic microwave background, known as CMB. The CMB is a faint glow of microwave radiation that fills the universe. It was left behind as the universe began to expand and cool from the intense heat and energy from the Big Bang. How do we know about this CMB? In 1965, two American radio engineers, Arno Penzias and Robert Wilson, were working at Bell Labs in New Jersey. They were testing a giant radio antenna, trying to use it for satellite communication, but then they kept hearing a constant annoying static ease, no matter what direction in the sky they pointed the antenna to. This static ease was a persistent low-level microwave signal coming from all directions in the sky, and it didn't just come from a specific star, planet, or galaxy. It also matched the exact temperature and frequency pattern that physicists and scientists like Robert Dick had predicted would come from the early universe if the Big Bang had really happened. So a different scientist made predictions about this CMB existing in the universe. And coincidentally, these two radio engineers discovered it. So why is this an evidence for the Big Bang theory? The CMB proves that there was a hot, dense beginning to the universe. Remember, the CMB is a faint glow of microwave radiation. An example is if a bomb were to go off in a remote location, there would be radiation left over from the intense heat and chemical components of the bomb explosion. And so, just as the Big Bang happened and the universe began to rapidly expand, from that intense heat and dense energy gathering around, there is still left over cosmic microwave background radiation. Another evidence for the Big Bang is the amount of hydrogen and helium in the universe. According to predictions on the Big Bang, the first few minutes after the universe began would have been so hot and dense to allow only the formation of light chemical elements. And so as subatomic particles began to smash together, hydrogen and helium began to form. Scientists have observed that most of the galaxies, stars, gas clouds, etc. is composed of approximately 75% hydrogen, 25% helium, and less than 1% of other chemical elements. This is therefore an evidence because the Big Bang correctly describes the condition of the early universe. Another evidence for the Big Bang is mathematical models and predictions. A mathematical model is like a set of instructions or rules that scientists use to describe how something works using maths. And some examples include Einstein's theory of general relativity, Isaac Newton's law of universal gravitation, Newton's law of motion, law of thermodynamics, and many others. So these mathematical models can help us understand how the universe and other things in the universe behave. It can help us predict how the universe began and how it's expanding, or even measure its expansion rate. These mathematical models tells us what we should see if the Big Bang theory is correct, what we can observe happening around us if the Big Bang theory is actually correct. Scientists have run simulations on computer and the results match real life data in many instances. If the Big Bang theory was wrong, we wouldn't expect all these predictions to come true. But the fact that the math matches the real life universe over and over means the Big Bang theory is a powerful and tested explanation for how everything began. For example, it is because we can calculate the gravitational force of the Earth, the speed at which the moon rotates around the Earth, or other mathematical calculations that we can fly rockets to the moon or do space exploration. That's not all the evidences there currently is to the Big Bang theory. But still, scientists in various fields are still researching and carrying out more experiments to bring up evidences that support the Big Bang theory. One of such scientific research and experiments is carried out in the largest scientific laboratory in the whole world known as CERN. CERN, CERN, when translated to English, stands for European Council of Nuclear Research. CERN has a Large Hadron Collider that accelerates subatomic particles like protons and ions at almost the speed of light to observe and analyze the resulting effects like the formation of new particles from the subatomic particle collision. This is all to understand the universe and the fundamental physics that governs our universe even at a quantum level. The Big Bang theory might appear to some as an outlandish explanation by scientists on how the universe originated. For some other people, belief in the Big Bang theory as the origin of the universe is not just based on making a leap in the dark with no evidence to prove its claims. So far, the Big Bang theory seems to offer a solid explanation and evidence for how the universe began. But is it the final word? In the next episode, we will explore some of the major challenges and scientific objections raised against the Big Bang theory, including concerns from Christians and even some scientists who argue that certain pieces of evidence don't quite add up. We will also take a look at how other scientists respond to these objections. You definitely don't want to miss it. So remember to give this podcast episode a like, drop your comments. Are there any objections you have? Are there anything you agree with? Drop it in the comment section and share this podcast episode on your status. Share it with your friends, share it with your family. Thank you very much for listening to the end of this podcast episode. I will see you in the next episode.